It's a little bit lower still. Jeez. Okay. All right. Next one is write the equation of the polynomial. Now, I'm not going to get to all of this, write the equation, but I will at least set it up. So let's just kind of go through each one of these. These are all zeros. So what you're going to want to do is write each zero equal to x, right? Because remember, like when we solve for like the zeros of a polynomial, then one way that we can write them is like x equals this. Right? These are like all the solutions. X equals this, x equals that, x equals these two. So there's some important things that are happening here. Like if I gave you, like for instance, let's just say I said solve x squared minus 1. Well, again, we could factor this to x minus 1 times x plus 1, right? And then we could use the zero product property, right? You can set them both equal to 0. And then x plus 1 equals 0. And then that's when you solve x equals 1 and x equals -1, right? So that's the basic idea from a quadratic, something like fairly basic. So our goal is basically to take our solutions, which we have written down here, now equal x, and write them as a polynomial. So to do that, first thing we need to do is set each of these zeros equal to 0. So we're just going to solve each of these. So this would be x minus 3 equals -I plus I. So x minus 3 plus I equals 0. This one then would be minus 2 plus 3i. So that'd be x minus 2 plus 3i. And this would be x minus 3 equals 0 and x minus 3 equals 0. Okay, so now once we have them equal to 0, now we're going to write them as a product equal to 0. So we're going to basically multiply each one of these. But here's where things start to change here. Now, again, we're not going to set these equal. We want to find the equation, so y or f of x or whatever you want to call it. The important thing we need to understand, though, is when we're dealing with complex numbers always call them what we call complex conjugates. So therefore, if we have -I, we're going to have positive I. If we have positive I, we're going to have -I. So for each of these factors, we need to make sure we include the conjugate. So x minus 3 plus I also needs to be multiplied by x minus 3 minus I. This one's going to be x minus 2 plus 3i. And this is going to be x minus 2 minus 3i. And this is what happens when we have, in this case, we have x minus 3 times x minus 3. Well, that's really a repeated factor, a repeated 0, which we use for our multiplicity. So this is going to be a x minus 3 quantity squared. Sorry, I need to take a drink. So what I'm going to stop there because basically now what you would need to do, I think I told the student on her spot, I'm like, that's a lot of multiplying. But you need to multiply these out, multiply those out. That's going to give you a trinomial. That's going to give you a trinomial. And that's going to give you a trinomial. So you're multiplying 3 trinomials by each other. I don't have the time nor the patience to